Hi guys, Shouvik here. Welcome back to YouTube channel. So today we will solve another question from Leetcode itself. So let's get started. Yes guys, so today actually a bit late for doing the recordings, actually like occupied with some priority office work. But yeah, keep them apart. We will solve this definitely on today. Yeah, so on today's question they have given an integer array nums of length n and a 2D array queries where queries I is li array. For each queries I, so what they have given a nums of length n, that is very straightforward, and a 2D array queries where queries I is li array for each queries I. So that is basically a boundary they are giving to you. What they are giving to you? A boundary they are giving to you. From L to R, you can perform certain operations using these queries I. Now what you can do, you can select a subset of indices within the range of li array in nums. So a subset is basically nothing but a subset of an array is a selection of elements. You can select any random elements. You can select any random elements in the range of li to ri, and possibly you can't select any of them at all, and do the following. What the following? Decrement the value at the selected indices by 1. What you can do, you can decrement the values at the selected indices by 1. But what you can do, you just have to decrement it by 1, that is of -1. You can do what is the value present in the nums. A zero array is an array where all the elements are equal to 0. Now after using the operator, now they have given a definitions of a zero array. A zero array is nothing but an array where all the elements are 0. All the elements are equal to 0. Now what we have to return, we have to return true or false. We have to return true or false if it is possible to transform nums to a zero array. So using what operations? Using these queries. Using the queries. In queries, you know what operations you can do, right? You can select any elements in the range of li array and decrement them 1 Like this way, you have to make your nums array to be a zero array. You have to make a nums array to be a zero array. Now after processing all the queries sequentially, otherwise return false. So this sequentially is not making any sense. That is just for like creating a divergence of your thought process. That is not going to be help, because it's very clear, right? So if on a sequential processing we have choices, in a li array, if an element is already transformed to 0, we are not going to perform decrement operations to that particular indexes, because we are allowed to select the index which we are like to do. A subset is like distinct index you can select, that is not contiguous, not like follow some order. There is nothing. You can select any distinct indices in the range of li to array, and you can do the operations of decrement. Yes, I think the problem is altogether very simple. Like on problem statement, I didn't find any like difficulty to understand. Yeah, now we can understand couple of test cases they have given to us. So that is the nums array they have given to us, and queries they have given to us 0 2. So what we can do, we can decrement this once, because we have a liberty. We can decrement any elements in the range of 0 to 2, in the index range of 0 to 2 by 1, right? So we can do from 0 to 1 and decrements the values at the indices by 1, and the array becomes 0 0 0, which is a zero array. So we are able to do so. So on this example test case, you can see like using these queries, like you at the very end you will be land on this state 3100. So it is not going to be like a zero array altogether. Yeah, so and your nums length is as big as 10 raised to the power 5, and num size is 10 raised to the power 5. Every element is also 10 raised to the power 5, and your queries length is also as big as 10 raised to the power 5. And queries of I dot length, it should have 2 elements only, like li and array, and all your li array in the range of nums dot length. So at brute, now if we can go to our OneNote, we can do a high level understanding of the problem statement. We'll definitely do that. So what they are looking for, it's working, no? It's not, no? Now yes, it started working. Yeah, so what actually they have given us. So let's suppose this is your array. A B C D E, right? A B C D. Now let's suppose we have a queries which is allowing us to perform operations in this range. They are allowing. So we can select any arbitrary. Maybe we can select this index, and we can select this index, and we can do a -1 to that indexes. We can do a -1 to that indexes, right? Like this way we can select the queries. We can select for a particular queries. We can select the indexes that we want to perform the operations, and we can decrement, right? So that is on the high level the problem statement is. So on very brute, now tell me guys, tell me the brute guys, tell me the brute. On brute, what we can do, we can, so for particular indexes, if we can run, let's suppose we are processing for I in range n and we are basically checking, we are basically checking. So that is your element is nothing but your nums of I, that is your element, and we have to check if we can make these elements all together to be 0 by using the queries that have given to us. Now we can iterate, we can run another for loop for j in range, for j in range nn is nothing but your length of the queries. Now you can increment, you have a count, so we have to find how many queries we have at which is basically able to decrements the element, which is able to which has the liberty, which has the power to decrement the elements which is present at nums of I. So we have start with its count to be 0, and how we can increase its count, if my like if I am running on j in range nn, so my queries of j of 0, that is our left boundary, our index is nothing but your I, where we have selected the index, or is have selected the elements, is lying in the range of queries of j of, tell me guys, queries of j of 1. So if that is the case, so this query has the liberty to decrease these elements by 1, to decrease the elements by 1. So on that case, I am going to increase counter plus plus. I am increasing the count. So we have a queries which is able to decrement the value present at the index I, right? And tell me guys, if at any particular time, right? If at any particular times my this query, this count, so that means like I have at max this many counts, this many queries I can perform to that particular indexes to make it 0, So if my count is altogether smaller than the element, so let's suppose my element is 5, and I have found 4 queries, I have found 4 queries. So using the 4 queries, I can't, like there is no way I am able to decrement 5 to be 0. At worst case, at very best case, we can decrement to 1, right? 5 minus 4 is 1, but not 0. So on that case, if that is the case, we can do a straightforward of return false. Right? We can do a straightforward of return false. Else, if we are able to process for all the indexes, then after executions of the entire for loop, after executions of this entire for loop, this, let's suppose this for loop is going to be ended here it has ended. After that, we can return a true. For sure. We are able to make it 0 array. So that is the brute. Now on brute, the major problem is this big O of n and this big O of nn. So the time complexity is boiled down to big O of n cross nn. So n is nothing but length of our nums, len of my nums, and nn is nothing but my len of my, tell me guys, len of my queries. So that is the multiplication of both, and now it is of 10 raised to the power 5, and it is also of 10 raised to the power 5, which is giving you a for sure of 10 raised to the power 10, which is what it is giving to you guys. What it is giving to you? Beautiful TLE, a beautiful TLE it will giving to you, right? So this solution will definitely not work for this particular question. So although the brute is fine, you can tell the interviewer the brute, but not the like pseudocode everything that you don't need to put, like this just for your understanding. Now after trigger the brute to your brain, what actually is taking the time actually? This Q factor, like running to in queries, running to your queries for every index you are running to your queries. You are checking all the queries, which queries are satisfying, which is basically taking time. So what I am interested on, so on brute, what actually we are doing? Tell me, like this is the point, guys. Like on this particular points, you should be like very focused, right? Because that is the point. We are converting our brute to the optimal solution. So see how from a brute we are getting the hints from the most optimal solutions. Like see the hints, like this way you can build your intuitions. Or maybe I will definitely suggest pause this video, try to your own, and then come back to this video. If you are stuck on that after like half an hour or so, then come back to this. Because on brute, your thinking process should be like in a good state to optimizations of the queries, to iterate on the queries, how we can process every elements in a smarter way. So now what actually we are doing? So if that is our array, so for a particular index, what actually I am looking for? I basically want how many queries. What I am looking for? I am looking for how many queries overlapped overlapped, right? How many queries overlapped to this particular index? How many queries has overlapped to this particular index? If I have this data, then I can tell true false, right? So that is the answer we need. That is the answer we need. That is the most important part. That is the answer we need. If I have this answer, then I can tell you. Then I can tell you. So now tell me guys, how we can build this, how we can build a kind of like overlapping for a particular index. What are the queries overlap? What are the queries overlap to a particular index? How we can build this data? How we can build this data? If this data is built, then the problem is solved, right? If that data is built, then the problem is solved. So we have to like answer for a particular index how many queries has overlapped. That now the problem is boiled down to this only. For a particular index, how many queries has overlapped? Yes, definitely. We all are agreeing. So now tell me. Definitely expecting like your intuition should be strong enough, like after solving like 70 plus problems, after solving more than I think 70 plus problems we have solved in 100 days coding challenge, and your intuition should be in this state. Your intuition should be in this state. You can think like how we can find how many overlap for a particular index. You should be, right? You should be. So here I am giving the hints. You can use some prefix, some kind of things. So for every queries I have a L, right? I have an L, right? So this is going to be contribute how far? This is going to be contribute till r, right? This is going to be contribute till r, and from r plus 1, whatever the contributions, what the contribution is plus 1, like everyone can, what is the contributions to this particular index? It's nothing but plus 1, because that is the count, like how many queries has overlapped, or this particular indexes from L to R, I have the liberty to decrement all the elements by one. So that is the liberty factor. That is nothing but our liberty factor. This is our liberty factor. Like we have the liberty from L to R, everyone's to be decreased by 1. But this, so this is our r plus 1th index, right? This is our r plus 1th index elements. This is our nothing but this is our nums of r plus 1. This is our not nums of r plus 1, whatever the prefix sums, let's suppose we have it, or any array elements, let's consider it. So we have from r plus 1, this liberty has decreased, this liberty gone, because we have this liberty from L to R. So from how then we can omit this liberty from this particular index? How we can like neutralize this liberty from this particular index? So I can do if let's suppose I am starting with a default dictionary, so or maybe let's suppose a prefix sum kind of things. I am going to be explain how prefix sums is going to be help here, but let's not consider it is an prefix sum. That is just for like you will get how it is a prefix sum. You will get that understanding. I have initialized a 0 cross n, like n size, not n size, like n plus 1 size, so that we don't need to check like out of boundary things. We don't need to check this. So I have initialized an n plus 1 size prefix sums, or a very standard zero indexed array. So when I am iterating to L comma R for LR in queries, right? LR in queries, and what I am doing, I know from L to R, it is contributing, it is adding a plus 1 power. So I am very good. I am just stating, okay, so prefix sum of L, can you add to yourself with a power of 1? So that means from L we have started a power of 1. But now if we are going to iterate from, if we are going to incorporate a loop for IDX, let's suppose in range L to R plus 1, if you are going to incorporate this loop, then it is again going down to be a big O of 10 raised to the power 10. So we can't do this. So that is not allowed. We can't iterate from L to R. So you are good. You are very good. Like you are stating from L we have the power started, but you can't iterate from L to R to add everyone's to be a power of 1. To add everyone's to a plus of 1. Sorry, to add everyone to a plus of 1. Rather than let's suppose we have to find a neutralization factor, because from R, the examples that we are discussing here, from L to R we have a power. Or reversely, can I say from R plus 1, we lost this power, How we can lose these powers? Minus 1. Whatever the prefix sums of this, you can add a minus 1. So that means from r plus 1, this power has gone, this power has gone, this power has gone. So just do this, then you can get the intuitions. So what I am stating of prefix sum of r plus 1, prefix sum of r plus 1, you lost this power, from L to R you have this power, from r plus 1 you lost this power, right? Now are you guys are able to see this beauty? What is the prefix sums now is holding? Are you guys are able to see this beauty? You should have, guys, you should have. So my prefix sum, let's suppose I have an queries. Let's suppose I have a queries of 0 to 2. Let's suppose I have a queries of 0 to 2. So from 0 the power has increased to 1. Then 0, 1, 2. This is again 0. Like on intermediate index we didn't perform anything. On intermediate indexes we didn't perform anything, because if we are going to perform on the intermediate index, when we are processing the queries, it is going to be again quadratic. So we can't do process in intermediate of prefix sum buildings. We first just set this is the start, this is your end. This is the start. On start we have add ones, and on end plus 1 we have decreased the power by -1. So on 0, 1, 2, here let's suppose we have -1. We have -1. Yes, agree guys? Yes, agree guys? Definitely agreeing. So now why I have declared it to a 0 of n plus 1, I think you guys have already observed this, because we are accessing an index r plus 1, and all of our L are in the range of 0 to n minus 1, that is within our nums boundary, but we are basically stating on one of plus indexes. So let's suppose that is your nums are 0, 1, 2, 3, and let's suppose you have a like 0 to 3. So then from start to end, or any particular index till end, we have certain power. So we can't decrease, we have to decrease to the ending index plus 1. In ending index of the query plus 1, we have start to decrease, because Li and Ri are inclusive. Li and Ri, we have inclusive powers from Li to Ri, not exclusive Ri. So we from Li to Ri, like including both, we have the power. So on r plus 1 we lost the power, right? So maybe on out of boundary index we have lost the power. So that is going to give you a out of boundary exception. So to handle this, we have declared it with n plus 1, so that it is never going to be do on array index out of bound. It is never going to give you such exceptions. So but let's forget this for now. What we are focused on this particular case. So like this way our prefix sum has built. Right? Now if I can do a forward prefix sums. Now after building this, after static pointer fish. So point 1 is static li ri pointer, static li ri pointer, addition and neutralizations. So we have done it. So we have done power additions, pointer power additions and neutralization. So we have add to be on li, and we have neutralized from r plus 1th. From r plus 1th we have also neutralized. We have add and neutralized. So first step is done. So now second step is after building this, do a standard prefix sums. On whatever the prefix sums you currently hold. So now if I can do a standard prefix sums, tell me how it should look. From 1 I have 1. After this 1 plus 0 is 1. Then again 0. So this is nothing but this. Now this plus this is going to give you this. Now this plus this going to give you an 1. Now this plus this going to give you a 0. So now are you guys see this beauty? Are you guys are able to see this beauty? Now my prefix sums is actually holding the counter. That we have solved on the brute force, or more specifically the overlap or the power. What is the power? What is the maximum I can decrease to a particular indexes? Every like that details, which details we are looking for, it's now actually holded by our prefix sum. So from 0 to 2, you can see we have a liberty to decrease every elements by 1. So it is holding that only. And from 1 to and after that we don't have any ones to decrease it more. So we don't have any powers at all. So that is the neutralizations it is doing automatically after you have done your prefix sums. After you have set your static pointer with addition and neutralizations, then do a prefix sums. Then you have your power summed. You have the powered state to the indexes, and after that it also neutralized. So now if I can going to take another example test cases. Let's suppose now on this case it is from 0 to 2 and let's suppose from 1 to 3. 1 to 3. Let's take this example. Now that is our queries. That is our queries. Now in this you will definitely get the gist. You will definitely get the gist. So on 0 we have increased the power to be 1, right? We have increased the power to be 1, and that is our 0, that is our 1, that is our 2, 0, 1, 2, and that is our third index. That is our third index. That is our third index. So on 0 we have power increase to be plus 1. Then at 1 we again have a power increase to be plus 1. Then on 2 we don't have any operations. We are not doing any sorry. On 2, sorry. On 2 there is a decrement. Sorry. So on 2 this is going to be decrement. So we have done a neutralizations. Not on this. Sorry. I have missed this. On r plus 1 we have to do, no? On r plus 1 we have to do. So on index 0, I have first 0, 1, 2, 3. So that is our indexes 0, 1, 2, 3. So when we have processed this query, we have plus 1 on these indexes and minus 1 on these indexes, right? Right? On very first go. Now when we processed our second query, so first query has processed. Now when we have processed our second query, this indexes is as it is 3, 0, 1, 2, 3. And on 1th index, at 1th index we have one set. At 1th index we have one set. At 2th index it's nothing but I think 0 only. And on third index, right, 0. On this index we have set. On third index, like 2 plus 3 is nothing but my this index we have minus 1, and 1th index we have started once and it is going to be occupied till 3. So we have initialized our prefix sums to be 1 plus size. So on this index we have again a minus 1. That is out of boundary, but to get out of boundary exceptions we have initialized with size plus 1, right? So that is our ultimate structure after pointer set with addition and neutralizations. Now we will do a prefix sums. Now this 1 is going to be 1, then this 1 plus 1 is going to be 2, this 2 plus 0 is again 2, right? 0 to 2, 1 to 3, and this 2 minus 1 is giving you a 1, and this 1 minus 1 is going to give you 0. 1 minus 1 is going to give you 0, which is out of bound. We are not looking, but we are looking at till this. So here you can see 0 to 2. How many at 0? How many overlap we have? We have only one overlap. We have only this overlap, right? On first index, how many? This overlapped, two. On second index, how many? This and this. So on first and second, we have two overlaps. On third index, only one. So on third index, we can see only one. And after this, we don't have any overlap. And this out of boundary also storing the correct data, because everyone has into third index. So after that, it is also neutralized to 0. So like this way, if you have followed these things, your prefix sums is holding the number of overlaps to a particular index, or the power, what is the power to decrement using the queries to a particular index. How much power we have it to make that particular index to be negative out. That is the maximum power is this particular index is holding of your prefix sum. So what is our formulas? First, statically set your L and R pointer by addition and neutralizations. And our second point is standard prefix sums. Our second point is do a standard prefix sum. So this, if we have followed these two principles, then this problem has solved altogether. Now we can do definitely a code iterations. Code is very, very small. What I have explained, that is there, but the intuitions, I think you guys are fond of loving these intuitions, man. Like if on very first go, I definitely agreeing that this is a kind of like difficult problems altogether, but not that hard difficult problems. That is a medium hard kind of difficulty problems, and also like you definitely solve a good number of problems to this particular topic. Then only like on any interview you can quickly like code it out quickly, like pull the exact explanations to within the interview time frame. So this particular algo you definitely have kind of a pre-knowledge, I have to say, but defining is also feasible, like based on the how much practice you are doing. So it's kind of a medium hard. I will going to rate this particular problem. Yes, so now we can do a code iteration. Code is very simple. I have declared n equals to len of nums, my prefix sums to be a 0, everyone, and size is I am declaring to one more size n plus 1, and I am iterating from LR in queries, and what I am doing on prefix sum of L, I am addition, static additions, and on r plus 1 static neutralizations, because we have power from L to R. Now we are doing for I in range n, if I is greater than 0, then only like we are basically taking. So here we are basically doing a standard prefix sums. Nothing general. So we are basically taking on prefix sums of I, we are storing what is the last value of prefix sums of I minus 1 plus of prefix sums of I. So on prefix sums of I, we are adding what is the prefix sums of I minus 1 plus prefix sums of I, what is the value present. So that is the very standard prefix sums we are doing. And we are only accessing when I is greater than 0, because for very first index, there is no one to be considered to be of its left. And from its right, we have an left elements which we can include to our prefix sums. Now this way our prefix sums is ready, and prefix sums of I is basically storing what is the maximum power or what is the maximum number of overlap to this particular index has happened. And if any particular time my prefix sums of I is less than my nums of I, so that means my counter or number of overlaps is smaller than my nums of I. So this particular nums of index though is not going to become a 0, not going to become a 0 using all the queries, So we should then and there return a false. We should then and there returns a false on that particular case. And if that is not so, then after the entire executions of this for loop, we can return a true. Yes guys, the problem and the implementation is as sneaky and as simple as that. There is nothing on like implementation. The understanding and the intuition building is actually the key. Now we can quickly discuss the time complexity. So on time complexity, I think you guys should predict on your own. This prefix sums is building is altogether going to be take a big of n. This iterations is going to be take, I am considering queries as big of nn kind of big of nn. Then this iterations again going to be a take of big of n. So this is going to be a taking of big of nn plus big of n. First one is big of n plus big of nn plus big of n. So this is actually n plus 1. And if I consider n and nn is as big as 10 raised to the power 5, so it is kind of like big of 3 into 10 raised to the power 5. 3 into 10 raised to the power 5 kind of complexity. Yes. Or you can write it like big of 3n. Big of 3n is definitely. Yes, not more than that. It is within of big of 3n for sure. And what is the space complexity, guys? We are only using our prefix sums. We are only using the prefix sums of size big of n plus 1. So that is the space. Yes, that is the time and space complexity. And I am pretty sure, like I am more than 100% sure, that is the most time and space optimized solutions you should be, like anyone should be achieved to this particular problems. And yeah, like my submissions is altogether kind of like 83, like more than 80%, 83% faster. And memory also it is kind of 90% faster. And yeah, like on analyze it's kind of a big of n only. So you can do you can say it's kind of a big of n plus n, or it's a big of 3n. They have written is n plus m. So n is the length of the queries, n is the length of the nums, and m is the length of the queries. And space, we are definitely sure it is a big of n for sure. So on space, you can see it is a big of n. So on space perspective, we are super good. We are 90% faster, and time also, like it is the most optimal time complexity you can achieve to this particular submissions. And if you guys are able to understand, so I know like explaining these problems, the intuitions set to your brain is actually very difficult to explain this. And if I am able to do so, please do subscribe to the channel, and please share the videos to your friends circle who are also preparing for top product-based company and brushing up their DSS. And please turn on the notification so that when we are going to live to our next video, you will get the notification as soon as possible. So that's it, guys. That's it for today. Let's meet tomorrow with another beautiful question. Bye, guys. Bye.